Okay. So, I wanted to go ahead and start doing some maker things. Basically, I've got a couple of projects that want to build, do some tutorials on, how to use 3D printing, the modeling software, so how to use Fusion 360, a bunch of things. So this is the beginning of one project that I hope to finish. And so let's look at a couple different things here. And you guys will just have to bear with me on this as I get things set up and try to do some things. So what I've got here are some... One second here so I can actually see. This is my first time doing all this together, so we'll see how everything works. If I need to adjust some things and move some things around, cameras, stuff like that. You guys are along for the ride. Okay, so obviously we got some keycaps right there. See yeah, there we go. Yeah, keycaps. So why the hell do I have keycaps? Well, what we're gonna do is right now you can see I'm using my mouse to control everything here with the scene in OBS. Anyone that has played around with streaming or used OBS or just played around with some things has probably heard of a device called Stream Deck, or anyone that's done any audio mixing or video editing, stuff like that. Basically what it is a thing that's I believe generally called a control surface. The MIDI term I believe is like a control surface. Anyway, the thing is it boils down to it's basically like a keyboard, right? It has special customized buttons that you can do, and you can assign things in the computer, macros, stuff like that. So that you could, in the case of OBS and the Stream Deck, you can switch streams. You can switch, sorry, not stream, scenes. You can, do kind of a whole bunch of things without, having to go in and use the mouse and click around and do things. It's kind of like a one-shot hotkey for things. But they're very useful. Like I said, you can use them for editing. I have one on my desk that I can actually move things around real quick to show you a picture of. It's hooked up and running right now, but I have a MIDI control surface that is a Korg Nano Control 2. That is a MIDI control surface that has mixers and faders and stuff on there so that I can adjust audio in real time with a physical surface. It just makes it a little easier. It's not necessary. You can do it all through the computer, but it does make it easier. So anyway, back to task here. So why do I have a bunch of keys? So what we're going to do is we're going to go through and we're going to try to build one. Is it going to be as fancy? No, of course not. All these are some keyboard switch caps that, basically these are the kind of things that you would find in your keyboard. If you take the keycaps off, you'll see these little switches here. And they just, I don't even know if you can hear that. They're not the clicky ones. These are just, who makes these? These are Gateron switches. I know a lot of the gamers out there will probably know that, there's Cherry MX, and then there's different kinds. You have black, blue are extremely clicky and tactile, and then you have, the brown keys, which are, I believe they're tactile, but they're not considered clicky. Anyway, there's different kinds, different things. They feel different, they type different, they make different noises. These are black, which means they are the linear. They don't really make a clicking sound, and there's no tactile. It's just a smooth motion down. Anyway, enough about the keycap. Who cares about that? So what are we going to do with them, right? So we've got a bunch of keycaps here. Actually, I've got a bag of them over here somewhere. My desk is a complete mess. We're trying to just trying to get by here with this small area that you can see is relatively clean. But So yeah, what are we going to do with them? So what we're probably going to do, and you know, things may change as we go along, but I think what we're going to do is go ahead and create a 4x4 matrix of them. So, you know, 4 across, 4 down, and you know, so we'll have 16 switches that we can write some software to go ahead and you know, configure what they do, everything else. So how do you get switches hooked to your computer? Well, that's where this comes in. So we've got, of course, an Arduino, and these, hold on one second here. These are not, damn, that thing won't open. I ripped it the wrong way. Let me get the scissors out. So, the special thing about this particular Arduino, there's a few of them, and there's other things out there that do this as well. And I just got this off Amazon, and it's just a, I think this is the Arduino Pro Micro, or an equivalent. It comes with the headers, so that's probably one of the first things we'll be doing is soldering these on. But basically, this has the chip that's on this, the Atmel. Which one is this? I forget which one it is. I cannot read that. The Mega 32U4. See if we can zoom in on that here. Yeah, I don't think that's gonna come out. This camera is not good enough. You can just barely see that there's writing on there. Anyway, this chip allows you to, emulate what's called an HID device. HID device is kind of speak for USB devices. HID devices are human interface devices, so keyboards, mice, stuff like that. So we can hook a number of things up to this, and then read the pinout values from the keys, and then translate that into keyboard macros, and we'll just plug a USB cable. I believe you would then just plug a USB cable into here, and then into the computer, and it'll show up as a keyboard. You press a button and things happen. You could, in theory, go ahead and build an entire keyboard and map it however you want, and then, you know, do this. Use it as a keyboard. It's kind of silly. You could probably buy way better keyboards than that, but, you know, if that's what you want to do, hey, you know, you can do it, just to say you built your own keyboard. So that's this, okay? So we've got this over here. Let me set this over here. Those there. This is just some extra parts here. So, I don't have... this is some old stuff here. I've also got some old... Not old, but, well, these chips... The mechanism of these chips have been around forever, and I probably don't need these. I have them in case we do need them, but I don't believe we do, because 4x4, I believe, the way we'll set it up, and I'll show a diagram, you do what's called a matrix. Now, there's advantages, disadvantages to doing things this way, but basically, I have to get a diagram to make more sense, but you create a matrix, you put in 4 values here, 4 values here, and then, you know, you put voltage over here, and then you read these pins. So you would need 4 input, 4 output. So you set this line high, and then you set this line high, and then you read all 4 of these. And basically what that does is if it allows you to figure out which ones were pressed at a certain time. That's a really bad explanation, but I'll show you later. It'll make more sense. So, you know, I keep showing you this thing. What is this thing? This is actually just a 5-volt converter. It allows you to use a USB source here for power. So it provides voltages here. This is what's called a breadboard. And you can see I've already got some chips in here. What this allows us to do, I don't actually know if these are spaced to, yeah, we'll have to figure that out. But you can see you've got like something like this here, and you can notice that, you know, we've got this chip in here, and this is actually really old project, actually. I don't know what this was. This was an Atmel project. This may be, yeah, I don't know what project this was. It's from a long time ago. But basically what these are a standard pinout spacing and everything, and you hook the microphone, you hook the chips in here, the microcontrollers, or any of your chips, and then you use these, oh, sorry about that, ran into you. Use these jumper wires to go ahead and, you know, connect certain pins together and everything. This is what you do when you're prototyping, just to get everything set up the way you want it. And then after you do all this, you go ahead and you create a integrated circuit, or you can create an integrated circuit board. You can have them shipped out, printed, whatever. We'll probably be using, I think I have it here right now. I'll have to look. We'll probably be using some perf board, which is basically the same pinout as this. You put the chips through, the pins come out the other side, and you solder jumper wires just like you would do this, except, you know, it becomes more permanent. The IC boards are obviously cleaner, but you know, they can take some time to have it shipped out. I don't have a method right now to do my own etching. I never got into that. It's a bit messy. We might be able to do that eventually on one project, but one thing at a time. So, all right, got the breadboard. We got this. We got the keycaps. Got everything here. What are we going to put it in? Well, that's what we're going to kind of focus on today. So, we've got a idea of you know, what we're going to do as far as you know, how things are going to be hooked up. What we need to do is go through and design a case for everything, or at least a general idea of it too. So we'll probably be looking at some of that today, just because I don't actually have all this stuff on my computer right now to program this. So what I'm going to do today is just kind of, this is just a dry run. We're you know, first kind of explanation of what we're going to be doing. We're not going to spend a lot of time today really digging into things, but I wanted to get everything started and get it out there. And you got to start somewhere, right? So I think the first thing I might do actually is let me grab the breadboard here. Let me take these chips off here. Grab. I'm gonna have to come up with a better setup, because I think I keep running into you guys. Okay, let's I also don't know where my yeah, just ran into you again. I also don't know where my chip extractor is, actually. Go ahead and put that there. And yeah, gotta find out where that chip extractor is. Well, these have been in here a long time. These might not. Oops. There we go. You don't want to bend the pins when you're doing things like this. I should actually be wearing a anti-static guard too, to be honest. But wrist strap. Yeah, should be doing it. Should be, but I'm not. But if I break things, it's my own fault. So I will just have to replace them if that is the case. So what I'm doing here is I'm just putting these in here to kind of line it up and hold it while I am soldering things. This is an old breadboard that really probably not in the best of shape, so it doesn't matter if it kind of gets a little messed up. I want to put this in here so that I put pressure on all the pins evenly. Probably don't really need to do that, but sometimes they can get messed up if you don't. Alright, so we got that there. See, because of the way I did that, these don't line up. Yeah, I did that wrong. Shoot. I move it over one more. Okay. Haha! All right. So, let's move some things here. Get that out of the way. Up. Hey, pull this down here. And this is something I recently made. This is a so I have a TS-80 soldering iron, and I wanted to make a soldering station for it. So I 3D printed this out the other day. Gonna be interesting to see if this ends up melting or not. Typically, you know, I leave it on the desk when it's on. So it's literally just, this is just used for storage. I don't plan on putting it in here, letting it warm up. I plan on, you know, leaving it here. Nice thing is, if you guys aren't familiar with this is USB-C powered. It actually uses Quick Charge 2, I believe. I don't think it's 3. It might just be, I don't know. I'm gonna have to look it up now. I don't remember. I'm second guessing myself. Oh, there we go. No, Quick Charge 3. Yeah. So it uses Quick Charge 3. So the nice thing about it is you can use any power bank that can supply. You know, is Quick Charge 3 compatible. Now, I did flash this with some custom firmware, which it was so long ago, I don't remember how I even did it. There's definitely procedures out there on the internet if you've got one. And the reason for that is it makes it a little more tolerable of battery banks, I've found. And before I flashed it, I had a number of even Quick Charge 3 power plugs that did not do well with certain things. It didn't like it. It would shut off. So this makes it a little more tolerant of things. I've just got this cable here I'm gonna try to use actually. But yeah, so I've got this this here that I believe, I think it supplies, I don't know actually, I don't remember if this supplies Quick Charge through the USB-C port, so we're about to find out. Let's turn this on. I'm guessing it does not. Alright, I've got this other one that I just got recently actually. This one may. Yeah, this one actually has an orange port. That says power delivery though. I may have to go just get my other cable, because I know if I use the standard USB to whatever cable, it does work. Where's the button for this? Button, where's the button? Oh, there it is. Come on. There we go. 51%. Jeez. Huh. Okay. Well, hold on one second. I'll be right back. I'm gonna go grab my other USB-C cable. I'll be right back. 1 second. Do. Okay. Alright, I'm back. Let's see here. So this one definitely should work. I've used this before on here. Might be a short stream if this thing doesn't work. There we go. Alright. So yeah, the nice thing is too, you can see this thing heats up really pretty darn quick. And I believe this is showing the voltage coming from the unit. So yeah, let's go ahead and set this here. Get this ready. Oh yeah, I can touch this, so I don't think that would be an issue in there. Alright, I don't know where my tip cleaner is actually. I'll just go ahead and do this, and then it's gonna be difficult. How do I do this without getting in your way? Actually, a little more light here. Can't see what I'm doing. Actually, I don't think I have another light, do I? I move that? No, that's no help whatsoever. Well, I guess long term I'm gonna have to get another light in here. Just so I can see what I'm doing. And so you guys can see what I'm doing. I haven't even been checking the chat, so you guys aren't telling me something's on fire while I'm not looking, because there are folks that can solder faster. To be honest, it's been a while. One of the important things I've found is some of the tips they tell you early on is that it's not actually the tip that makes whatever you're soldering hot. I know that sounds counterintuitive, but the reality of it is solder making connection to the pin that transfers heat. You want to make sure you have solder on the tip of the iron. Move you around here. Can you still see? Yeah, you can still see. Can you see clearly though? That's a good question. Let's see if we can get you in here a little closer. Maybe. Oh yeah, it's my foot and my leg. That's quality television right there. Quality streaming right there. There. Let's see here now. There we go. Sure the got done. And accidentally done. Not the end of the world if it does. Bob Ross. Happy little accident. Also gonna preface this with, I don't do this for a living. Probably better ways to do things. In any of these speaker vids that I might make in the future even too. This one doesn't. why that one ground pin doesn't show, but I mean... I think it did go. Yeah, like I was saying, for a living. And, quite honestly, it's been a while. Not too bad. How's it looking there? Yeah, there we go. So we got all our pins soldered on. So there we go. So let's, now that we get that done, we'll go ahead and unplug this. We'll try not to set anything on fire. Turn that back in a little. And let's move you back up here. Refocus you on the useful things. One of these days I'll take a picture. I'll use another camera to take a picture of my camera. This camera actually was a the one that you're viewing everything through. It's actually a kind of El Cheapo camera I got from Amazon. It's not the best quality. It actually it's pretty good. But what's nice about it is it's manual focus, so that's why it's not, you know, going all over the place while I'm moving, and I have to keep adjusting things. And I have to keep checking to make sure that you guys can actually see without it being blurry. And, yeah, there you go. You guys are chatting. Sorry, I'm not getting the notification that there's, noise for some reason, so... let me... There we go. Turn that up a little. Maybe now I can hear you guys. So yeah, the camera itself was from Amazon. It was an El Cheapo one. It's manual focus, and it's actually got a pretty wide field of view. And it doesn't do a bad job picture quality wise. It's not the best. There's better, but I think it was only like $15 or $16 when I got it too. So what I had to do, and I'll take pictures of it, but what I had to do was go through and I just 3D printed, modeled and 3D printed a new case for it, so that I could have a much easier knob to turn for the manual focus. And now I've got it. There we go. Now I can hear you guys chat at me. I had it turned down by accident. Sorry about that. So yeah, it comes through pretty good. It's not my DSLR. I have that hooked up too, but this is wider angle for these closer shots and stuff. So we'll try using this, and it gives me more option to move around. So this should... Yeah, that's cooled off now. So now we've got this set up. We've got the Arduino. We've got our pins on here. We've got everything soldered on. So what I should do... normally what I would do now is probably go to the prototyping stage. So I would go through and plug that in, plug a keycap in somehow. I don't know how the hell I'm going to do that. I'm going to have to get... I have some... somewhere. I'll have to find them for the next vid probably, but I've got a bundle of these jumper wires. Like I said, these jumper wires are supposed to go, you know, from here to here. Actually, what I probably need to do is key switches. What about the key switches? They're right here. Key switch. I don't know, can you hear them click? There you go. I'm gonna take these out of here. Not keycaps. What about keycaps? Yes, they are actually. They are Gateron Blacks. Good eye. I got those because I'm not familiar with them. I'm familiar with the Cherry MX keycaps, but these were cheaper, and you could get a bigger bag of them for less, so I figure we could get these, try them out, and I could see how they actually respond for like a keyboard or whatever. And then, you know, we have some extra to make some projects. I'm thinking maybe that what we could do is have a raffle at the end of this and see if Carson just got Kelly Box Pinks. I am not, believe it or not, I guess I'm a bit of a snob because all I really know are about the Cherry MXs. So I'm gonna have to go watch some videos because it's been a while since I've gone ahead and looked at mechanical keyboard switches and some of the brands that are out there. So cool. Yeah, so normally I would, like I said, go through and prototype things, but because I don't have all the stuff around right now, because I'm in the process of cleaning and trying to get things together as I can. So normally what I would do is I would hook up the voltages. Cherry MX Blues. I love the MX Blues because I love the clicky keyboard. I used to have one of the old original IBM PS2 keyboards. Why not just use the little switches for the prototyping? Well, I can still use these switches. But the issue isn't so much the switch. It's I don't actually have Arduino what do you call it? The studio set up on my computer for this yet. I realized that as I started the video that I can't go ahead and do that part because I don't have it all set up. So I want to get that set up first and make sure I can talk to the thing and everything before I go doing that. So today what I'm going to do is probably just do the 3D print housing and show you how I do the measurements and all that for that to do the modeling for that part. Because I at least know layout wise what I want to do. Like I said, I'm going to have, if you were here at the beginning, I'm going to have 4x4. So I want to go ahead and do a layout for that for a piece. I got to figure out how... I'm going to have to evaluate how these snap in so that I can create a piece that these can snap into, and then we'll go from there. So we'll probably start with that, and I'll create a test board to go ahead and, snap these in for fitment and everything else, because printers aren't precise. No matter what you try to do, the 3D printers are not precise, and also the plastic shrinks. So it does shrink and deviate from the side size, so you have to adjust for that. So you usually print one thing, you just print a small piece to test fitment of things, and then you go through and you print the board and you see how things lay out, and then you kind of move on to that. So that's what we're going to do for the prototyping. But basically what we're going to have to do eventually, and I'll have diagrams for how we're going to hook this up too, because I think I can just do a matrix. I think there are enough input-output pins. I think this has 10 or 12 digital I/O pins, which we're going to need 4 in, 4 out to do a matrix, if we do a simple matrix. If not, I have some of the 74 series logic chips to be able to use what's called a shift register. And even if I don't do that, I'll probably do it as a prototype just to show what is a shift register. Just because it's cool stuff. I think it's cool. If no one else does, then no one will just watch and I don't care. I'll sit here and talk to myself. I'm good at it anyway. So that aside, let's go ahead and get the calipers out and start measuring things for that. And then we'll get back to the wiring and the electronics side on probably a future video. So let me move over here. You're gonna have to bear with me. Let me move some stuff around here. Because I am going to have to try to share Fusion 360. And I think it will work. But let's see. So let's get our calipers out. Yeah, these are a little... I think I need to replace... Yeah, you know what? Let's pull the battery out and replace it. 1 second. Of course, these have been sitting in there forever, so who knows if... No, that's a lot better. I can actually read it. It's been dying for some time. I needed to replace it. So there we go. Throw that away. Okay. Make sure we're zeroed out. Yeah, okay. So, what we'll need to do is we'll need to get measurements. Let me take a look at this here. Let me... What we've got to do... We've got to figure out how... I'm trying to keep this in the focus zone here. We got to figure out... So there's a detent here. So we'll have to measure... So we'll have to have a piece that goes across here with a detent here that kind of relieves so that it locks into place. There's a ridge here and the same on this side. This is probably pretty standard. I could probably go through and find something online that describes the CAD dimensions. But a lot of the stuff I do, you know, and a lot of the stuff I make, you know, there's not going to be CAD dimensions for, so it's important to know how to measure things properly, or at least, you know, go through and measure things and adjust them so that you can do that when you can't rely on measurements. Or you can't rely on having the measurements already, sorry. Okay. So, let me pop over here. Yeah, they should be pretty standard. Pull up. Come on. 360, let us go through. Refocus that blurry cam. Turn it off. Let me see here. I need to adjust some things. Or not? Guess it just told me no. Oh, duh. Let's do that. There we go. So let's hold on 1 second. Fit the screen. Yeah, let me move this around here because I've got it on my big monitor here and it's making things. There we go. Now that's probably a lot easier to read. Let us set this. Like I said, I didn't, I should have and did not set all this up. So, just the microphone here. Come on. You're gonna hear some noise. What the hell happened here? There we go. Alright. Probably sounds a little better. Probably sounded okay, but probably sounds a little better now. Reset. There we go. I don't know, you can see in the bottom of my desk there. Whatever. Yeah. So let's go in here. I don't know why it automatically adjusts and automatically goes into this other project. We'll go into our new project. You can see all of the stuff I have on here. So let's do projects. Power fur remover. I'll get back to that one day. What are we gonna call this one? This is a stream deck. Let's do a I'll just call it stream deck. Yeah, we'll go in here. So we've got our design by default. So what I usually do is, and again, this is just the way I do it and the way I've learned to do it so far, playing around through Fusion 360. You may not use Fusion 360, you may use other programs, but I think a lot of the things are similar between the CAD programs. Or like Fusion 360, it makes sense to me. I used to use OpenSCAD, which was originally easier for me as a programmer to figure out, just because it's kind of like a definition of things. Yes, the power fur remover was for a pet. So it's what I had tried doing was quick explanation on this one. You know, with us having well, at the time we had the one dog and now we have two, and we take them everywhere we go, and we have a black van with black carpet, and we have a tan dog and a black and white dog, so of course their fur goes everywhere. So I'm constantly using I forget what it's called. It's called a lily brush is what it is, but basically it's a it's basically a piece of plastic with a flat thin sheet of rubber on it. It's hard to explain. Kind of like a squeegee, like if you squeegee a window or whatever. But it's a little bit of a harder rubber. But you rub that on the carpet, and it pulls the fur out of the carpet. It does a really tremendously good job. And I the last time I did it, and it's a very painstaking process because it does take a long time, and it's a lot of carpet to do. I had gone through and thought of, hey, you know, why don't... If you had this rubber belt, then you could just kind of like, you know, have a motor that would like twist the rubber belt. So I, you know, came up with this idea, and you know, here's the housing and stuff for it. You can see to a degree it's transparent right now, but there's a plastic casing. Here's the rubber belt. The idea is that the rubber belt will go around. Unfortunately, and this is the first thing I printed in. I printed the belt in TPU, so it's soft rubber. So it does actually work as far as going against the carpet and pulling the fur out. The problem is, due to the nature of the way you 3D print, like you can't use it as a belt. There's layer lines and everything else that makes it rigid in certain directions so that it doesn't actually... It's flexible material, but it's not going to flex like a belt. So this idea is just not going to work at all. I'd have to get... or I'd have to find some rubber belts or whatever that would work this way. So this is put on hold for now. You know, eventually I'll come back to it with some ideas on maybe, you know, some type of material I could use for the belt, and then I could work the rest of it around it. But anyway, so that's what the power fur remover was. I'm not going to change that. I'll turn that off. So let's go ahead and get a measurement. So let's switch back here to this, and let's see here. The first thing I'll do is go ahead and create a sketch over there. So, actually, let me flip back because I'm a little spastic today. Well, more than normal, I guess. So that's what I was starting to do. I've gone ahead and I've created the sketch, and you can see I'm in sketch mode here. And what I want to do is I want to create a rectangle. So I want to model the size of that thing. So that is... I'm going to go here, and you'll see that pop up there, okay? And then you can usually just put the dimensions in directly. We're just going to pick dimensions here for now, and we'll put them in a second. So let's hop over here. See, this is why the Stream Deck would be useful, because you could press a key, and then bam, you're over to the other thing. I could set up hotkeys, but I'm not there yet. Okay. So, got our keycap. This thing is... Overall, with the ledge, we are 15.9 by 15.7. 15.6. Yeah, 15.6. 15.9 by 15.6. Okay, so let's hop back over. I'm going to actually write that down, probably. Just remember that for me, because I'm going to forget it in about 3 seconds. So we've got 15.9, I believe, and 15.6. Now let's check the orientation of that, because that was, what is that? Yeah, so the 15.9, you can see my arm in the background there on the bottom. 15.9. Yeah, I've got them the wrong way. So let me fix that. So we got that there. Did I say... Am I saying keycaps? Is that why you keep yelling at me? I don't even realize it. I'm just gonna call it a key and annoy you really bad. If that's the case. Damn. Okay. Sorry about that. Keycap. Yeah, that's the other thing. Eventually, I am gonna have to actually make keycaps. I'm either gonna have to pull them off of an existing board, which I don't really have one to spare. So I'll probably be 3D printing some custom keycaps. And I do mean keycaps. So that ought to be interesting too. I don't recommend probably doing that for your own keyboard because they're probably going to come out pretty rough and they're probably not going to handle like typing every day or use. But you know, if you wanted to build a custom keycap for... in fact, I'm sure there's already ones out on Thingiverse that I've seen them that you could print. But I'll probably go through and do that and actually resin print them maybe and make them extra fancy. But I don't even know what I'm going to use them for, so... you know, we'll see like which button does what, so I'll probably just do standard things. Cap, switches, plate, or PCB. What? You talk about printing all of them, or I don't know what you're asking. I don't think I'm gonna do I really should ignore it. I can do that. I think I said before, I'm not gonna do a PCB. I'm probably just gonna use what's that called? Perf board. I do have one around. I just had it earlier, but it's just through-hole perf board. I'll probably just straight wire the key switches on, just because it's going to be easier. But anyway, so we've got this here. So we've got 15.9 by 15.6. And then what we're going to do is check the indent between the key here. Yeah, so if we go over here, we want to measure this indent here. Gigantic finger. We want to measure without the lip, how wide is this? So this is actually... I'm gonna look at it here to make sure I'm doing it right. We got 13.7 here. This is what we're looking at. So 13.7. So let's go ahead and check. Measure twice, model once. The new saying, right? Yeah, 15.9, 13.7. Okay, so what we'll do is we'll go ahead and create a another rectangle here, and because you snap it on here, it automatically constrains it to this line. So what we can do is we can sketch a dimension here, and we can tell this to be 13.7. Yeah, there we go. And see, it moved down. So now we want to make it equal. So what we want this to do is we want the midpoint. We want these to be even. So what we can do actually is you can do math in here, which is pretty cool. So what is the distance here, right? So the distance here is going to be 15.9 minus 13.7. Right, that's going to be the total. Like if this were shifted all the way down, it would be 15.9 minus 13.7. But because we want it in the center, we get it divided by 2. So we'll go ahead and do this. put that there, and we'll tell that this. We'll say take this, subtract this, and we don't even have to do the math. It'll do it for us. And there you go, 1.1. Now, if we go down here, it's going to say we're over constraining it, but you can see, like if I try to put this, it'll say you're over constraining the sketch because we don't need that dimension. It's automatically calculated. But we can see, I'm just putting it there for reference now. They're even, 1.1, 1.1. It's automatically centered. There might be a ridge. It's possible there might be like a little ridge on the top bottom, because there is for these, at least. On the one side, there is a ridge that kind of like snaps in. I don't know if you can see it. And it might be that these keycaps are different as well. So it's very tiny. So, I mean, it might not be that easy to see. And I don't know if you could see it here. And it would help if I made it focused. There you go. So, if you look... not fall out of my chair while I do this. Not run into the microphone. Man, this is difficult to do. Need to look at the part here. You can see here there's this little gap, right? This little gap here. So this little piece here sticks up minutely, probably like maybe 0.5 millimeter from here. And it's just a detent to snap into, just to give it a ridge to make it a little sticky when it goes in there. So we don't have to do much. We could probably get away with, to be honest, because we are going to be pressing on it most of the time, we could probably get away with not having to worry about that. And because 3D prints automatically have layer lines in it, as long as we're printing this way up, there are probably going to be ridges that this can catch on. But we're not going to rely on that. We're going to go ahead and take that measurement, and we're going to make a little detent here where these go, so that these pieces like snap into there, right? So that's what we're going to try to do. But the thing I'm modeling here isn't the detent, it's actually the ledge, right? So if you look at the keycap, there's actually a ledge over the side that this rests on to keep it from pushing all the way through. So that's what this is. This part here, right here, this is that ledge that's on the keycap, right? So when I model the hole, right, this is the keycap through part that's going to go through. So this is the hole I actually need to make. This is the resting ledge on the keycap that it will sit in to keep it from pushing all the way through. So this is actually the hole I need to cut out. I'm not actually modeling the hole yet. I'm modeling the keycap itself. I'm sorry, the key switch itself. I did catch myself that time. I am modeling the key switch itself so that I can refer to the dimensions when I need it, right? Because I'll show you what we can do here and how we're gonna go and do things, and then we'll go from there. But I think you are right. We could probably get away with just having the detent there and not having to do much. But we'll find out in the test print whether that would hold or not, and we'll go from there. And if it's not perfect, it doesn't have to be perfect. As long as it's not like all falling apart when you go to move it, that's really all we need. And you got to make sure that it's tight enough to like hold everything in there, and that it's not too tight so it doesn't go in or without things breaking. So let's see here. We've got all that there, so I think we've got enough with the measurements. We'll probably need to know how deep that is, but that's another measurement. So okay, so we've got that. So here's what we can do. I'm done with this, so what I can do is I've got my keycap sketch. I can leave that one alone. Let's go ahead and create another sketch now in the same plane, And rather than modify, you know, our original sketch, what we'll do is we'll take this hole, which is the through hole for the switch itself, and we will hit P, and what we'll do is we'll project that geometry onto this sketch. So let's pick... I don't want that. I just want... yeah. Sometimes this gets tricky. There we go. So there's our 4 sides. We'll tell that okay. So we want a bit of a gap. So let's see. Let's take a look here. And I kind of eyeball things just to figure out like how much of a distance I want for things. I'll just look at the measurement on the caliper. I think I want probably like a 5mm gap between the keys. I think, like, if I measure my keyboard, I think it's actually, looking at it here, I'm looking at about 3.5. If this is right, this is about a 3.5mm gap between the actual key switches themselves, because the key caps are a little flared out. So I'm going to go ahead and be a little extra, do a little extra on that, and we're going to go ahead and probably move it up to about 4, meaning there's going to be this big, 4. It's hard to get it exact when you're dealing with those very small numbers. We're going to have about this much space between one key switch and the next, and then from left to right and from top to bottom. So let's jump back over here. So what we're going to do is, like I said, we want to go ahead and do that. Actually, that's a good point. I want to go ahead and create a rectangular pattern. Okay. So I want to take this box, and for now, let's do one direction. And we want spacing. We want a direction to go. Stop. Our objects. First, we need our objects. There we go. And now for our direction. I don't know why it's not, why can't I select a direction here? Do I need... distance. Yeah, why am I not... Oh, suppress. Why is this not doing... No, because I gotta pick the direction. I haven't used this much. The rectangular pattern. I usually use the circular pattern on things, so you're learning when I learn here. I think maybe I need to go ahead and do a construction line and say I want it to go this way. Maybe. And then I can choose that as a pattern. So let's go ahead and select that and tell it rectangular pattern. There we go. Yeah, see, it wasn't giving me this before. That is what I wanted. Yeah, and I want spacing. I want our distance to be... Wait, what? The spacing is the entire, right? Yeah, okay. So let's just eye it up. So that is 8. So these are 15.6. So if I wanted it to be, I don't want spacing. I want, what is extent? Is the total, yeah, extent is the total width. Spacing is this. So I want it to be 4. So 16 just kind of lines it up there. So then we'll do 4 more. So we'll do 20. Because it includes the width of the object itself. So now we should have roughly, let's tell this, we don't want it to be a construction. Yeah, we should have roughly 20 between us. And then same thing down here. We want these to go this way. And we want negative 20, right? There we go. And see, this is why we want this reference here, because we want to see, like, are these going to interfere? Because we need to remember, it's not the distance between the holes that is the spacing between the holes that's the issue. It's the spacing between the key switches themselves that is the issue. Because when I measured my keyboard, I measured here. So we're going to have a little bit of a difference, and that's fine, but that should work. Tell that okay, and there we go. We've got our rectangular pattern for all of our key switches, and it's that easy. So now what we want to do is we want to create a rectangle around all of this. Well, actually, we don't want a construction line. Construction lines are just used for like reference points. At least, I don't know what the official use is, but that's how I use them. I believe that's how they're supposed to be used. But they're just reference points for building off of. So let's go ahead and do this. We are going to... We've got all of our... Let's hide this. Okay. Let's go ahead and fix these, because we don't want these to move. We want everything else to move. We want everything to be relative to them. So, we want... that there... And we want this to be even everywhere, so what I'm going to do is go ahead and do this here as well, but I'm going to tell this, reference this, same in this dimension, reference that, and then of course we're going to do that here as well, get a reference here. So now when I change this one number, they're all linked together, so that if I change this to be 10, I'll end up with a margin of 10 around all of these. So let me look at the width of a keycap, an actual keycap, not a key switch, a keycap. So our width of our keycap, they're roughly, what, 18 by 18. Okay, so that means if our, I believe we were 15.6, so that gives us, what, 3, so 1.5 on each side. So we're gonna have, if I do 10, I have a gap of 9. How's that look? It's not so bad. Let's do 7.5. No, let's leave it 10. 10 is fine. That, actually, you know what? Let's bump it up to about 12. Purely design decision, but we'll do that. Okay, so that's it. That is our board for all the keycap, or sketch rather. So now we've got this flat sketch. It doesn't do anything, right? So what we're going to do is we're going to take this and we're going to select the, the actual piece here. And we're going to press pull, and we're going to, or you could do extrude as well. But we're going to extrude this up. Let's zoom this out here. We don't want 10. We don't need this to be super thick. Probably, if I look at the keycap itself, the entire keycap, and I know I'm not showing this on the cam, but the entire keycap portion that goes below is about 5. If I take into account the leads, it's about 7 or 8. So maybe I do actually need that pretty thick. So let's go ahead and make this actually, hold on, getting ahead of ourselves. I don't need to. Let's make this 4.5. Let's make this 4.5. We're gonna have to adjust all this probably sometime in the future as well, just to get things straight. Okay. So this is just our test plate, so we're going to go through and probably gonna stop here, I would imagine. Just because we're gonna have to stop, we're gonna have to print this out, we're gonna have to test it, see how it goes. If it works well, come on. And what we're doing is we're selecting these edges because squares are boring. And, we can't do anything nice with these because they've got to be shaped that way so that the key switches snap in. But we can make this rounded, so that's what we're going to do. We're going to go ahead and give this a radius. What was this? This was 12. So there. And then we'll take this. Here. And let's roll this edge a little with a little fillet. Nice roundedness. Okay. Looks nice. Okay, so this will be the front, right? So this is going to be the front of our object. The key switches will snap into this from this direction, and then we'll have our keycaps on. And then this should be enough distance between all of them. If not, we can adjust the sketch, and we can go through and do things there. And we will go ahead and do that if we need to adjust things. So I guess what I can do now is I can export this, go into Cura, print it out, and that'll take a while, and we'll do a test fit. But before we do that and we end the stream, let's think about, like, you know, how is this going to look? We're going to have to figure out how this is going to sit on the table, everything else. I'm guessing we're probably just going to have some kind of, like, sloped base, right? So what we could do is we could go from the bottom here, and we could take this, and we could go ahead and grab all of these as well. We don't want that, because we don't want the, we want all these. No, we don't. No, we don't. No, we don't. Nope. 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 Let's create a new sketch. Right. So let's grab this and all these. Right. And there's a reason for this. And we will project that in. Actually, I don't think I needed to do that. I really just want these. Right. There we go. Sorry. I don't always do things the right way at first. Brain's got to catch up a little bit. 9. That doesn't add up. No, I'm missing one. Or I've got one too many. There it is. That's why. I've got one too many. Tell that okay. So now I should be able to hide everything else, and now I've just got my stuff here that I wanted. Okay. I want to trim these because I don't want those there, right? What is that showing me? Is that showing the model or is that showing the... Okay. So what we have to do, actually, I guess these are the things... We're going to have to make that front part a little bigger, right? Because we've got this here. Okay, and this is our top plate. And we're going to have a bottom container to house everything. Which is why we can't kind of go and do that yet. Because we've got to figure out the wiring, we've got to figure out all this other stuff, and what we've got to stuff in there. And how much space we need to do it. We shouldn't need much. Those, you know, you saw the Arduino, it's not that big. The wiring shouldn't be that big. It should just be a matter of, like, you know, creating a spot and putting the Arduino down in a spot that... you can go through. In fact, we probably don't need, when we get done, we're probably going to use one without the headers on it. I just put the headers on to be able to use the breadboard, but we're probably going to just use one that's headerless and just kind of wire things direct. Especially if we're not using the 74 logic chips, if we're not using the shift register, then we don't have any other chips other than the Arduino and the key switches and some wires. So we don't really need to be doing a lot. So there shouldn't be that much in there. So if that's the case, it should just be a matter of, like, creating enough plastic to house and hold the Arduino in place. But what we will need to do is we're going to need to put some drill holes here so that we can put screws in to affix this plate to the bottom plate so that we can have the two pieces, you know, put the bottom in and go from there. So, yeah, we can't kind of do that yet. We've got too much up in the air. We've got to figure out first, you know, how everything's going to fit in there, whether or not we need that logic chip or anything, because that could change the way this is going to look. We're either going to have a bigger perf board or we're going to have that little Arduino board. Not by much, but it will change things. And we'll also have to worry about, you know, having a notch out, because we got to be able to let the USB cable in so that you can plug it in. So we have to think about those kind of things too. And probably some other things that I'm not actually thinking about. So we'll leave that sketch there for now, because what we'll eventually do is we will come back and do something like this. We'll go through and grab this. Yeah, those things are there. I don't... I think it's because it was originally there, part of the sketch, or part of the, what you call it? Yeah. Yeah, see? I don't know why that's like that. But what we'll do is, we'll inset... Well, I'll go ahead and do it. Might as well. ADD Theater, right? We'll grab this, right? And what we're going to do is we're going to inset that in. So what we want to do is we want to have a shell of plastic. Looking at my calipers here to get a good bead on size-wise. Probably want to have it be about 2.5 millimeters. Now there's probably better ways to go about doing what I'm about to do, but it's just the way I thought in my head how I'm going to do this. So if we want a 2.5 millimeter perimeter, we've got to double it, and we've got to say that this is going to be inset by 5, right? No, right? No, I'm doing that wrong. That's 10. We actually want it to be 2.5 in, right? Sorry, I'm doing math differently. There we go. So now we've got 2, okay? So what we can do now that we've got this here, we can go ahead and take the whole thing, and we're just going to make up some numbers for now. We're going to look at the top here. We're going to select everything, and we're going to go ahead and extrude this, okay? We're going to extrude this down. And it's yelling at me because I don't have this on. So let's go ahead and let's hide that, right? So we can see it. Let's say we're going to need this to be about 25 millimeters, right? Okay. We'll go with that. So we'll tell that okay. And then obviously this isn't going to work. It's a solid block, right? So we'll turn this on here, and what we're actually going to do is we're going to grab everything again. Alright, but this time what we're going to do is we're actually going to unselect that portion, right? The lip that we don't want. And now if I turn this back on and we go ahead and we tell this we're going to extrude this again, you'll notice that there's an option here, operation. We can actually, you can do a join, a cut, and what that'll do is if there's another body that the object is intersecting into, and by the way, these are sketches, and then these 3D objects are actually the bodies. So if I go like this, automatically it should determine, hey, I want to do a cut. So if I go and do that, and then I tell it, hey, if I click on the bottom of this body here, it'll automatically set to the distance, and it would actually cut a hole all the way through. Now we don't want it to do that. We want to do a, we want to go up and make it, I think our perimeter was too, actually, let's make it the bottom a little thicker. It's probably going to be, yeah, so we'll do 5 there. So now what we've got is we've got our shell, right? We've got our shell that we could put the lid on, and there you go. So obviously we have to drill holes here. We're going to have to go ahead and create some cylinders here that the screws can go into. Mounting wise, or what we could do is round these corners out here and drop it down on so that, you know, they would just go here and not have to do the whole thing. There's options there. Use less plastic that way and give you more room. We don't need the room because there's not going to be much going in here, so we could probably just do it all the way down and be easier. But we can modify the sketch for that later. That's the nice thing is this is I'm forgetting the name. I've been sitting here for a few minutes now trying to remember. what this is, the nice thing about Fusion is that it's this specific type of design. Now I'm gonna have to look it up because it's really irritating me, because I always talk about it when I'm telling people about why I like Fusion. But the nice thing is I can go back and change things as I go along. So if I determine later, and that's why this isn't a big deal doing it, because you see I've got my history roll down here. I can determine that, hey, I originally did this, it was 25, I really need it to be 30, so I tell it 30, okay, and there we go. With this one, because it should have, but did not, this measurement, because this measurement should have been based on the bottom, it should have, like, you know, auto-corrected, but it did not. So I could go ahead and say, you know, hey, I need to make this 30, and bam. I think I did that wrong. What did I do? Oh, I changed it from 25 to 20. Whoops. If I make this 30, bam, it's updated. And then anything down the line automatically gets updated too. So if I had things based upon that depth or whatever, like, you can go ahead and create sketches off faces, and those... that sketch is bound to this face, so if the face changes, the sketch position changes as well. So it's kind of handy. To a degree, there's certain things where you get to the point where the geometry changes so much it can't auto-calculate it, or it may not do the thing you want it to do. The other important thing is, I'm going to save this, because I haven't saved it yet. So, because this is our prototype, we will go ahead and do that. Put that on. So now, what, you know, we've kind of got a rudimentary box that we're going to go through and model, and we could print out and everything else. But for now, all we need to do is test this to make sure that these key switches fit in here, if we need to make adjustments, if they're going to be too close together, stuff like that. So what we'll do is we'll go ahead and save this as an STL. And you don't see it, but it's... popping up asking me where to save the file, and I will go here and save it on my network drive. Where do I want to put this? This is... create a new folder just for you guys. Twitch streaming. And this will be our Stream Deck. And this is our top plate. And in reality, what I should do here is rename these. So I should rename this top plate. And this should be bottom housing. You name it whatever you want. That's just what I picked. I'm also notoriously horrible at naming things, so... any of you that have ever seen my code would know that. So there we go. We've got our start. So now we get to the boring part where this is probably going to take... Actually, this isn't that big. It's probably not going to take that long to print. Let me go ahead and open up Cura. I've already got it open over here with another project I was working on. I'll go ahead and remove that. And switch Windows... Second. Where is Kira in the list? I can never find... There we go. Yeah, I don't know why that did that. Okay, great. There we go, Kira. So let's go ahead and we will open our file. I don't know, I guess you gotta share the whole screen for that to pick that up. That's weird. But I will go down here in the 3D print. You'll just have to use your imagination that I'm going through and opening files. And I will open the top plate STL. I have not yet been able to fix this. And if there's ever anyone that watches this stream that knows how to actually use Fusion 360, this is one of the most irritating things I always deal with. They always come oriented so that, I don't know which one it is. I guess it orients so that front is bottom when you export an STL. And it's not a big deal to fix. It's just really freaking annoying that every time I open anything I've modeled, you've got to go through here and you just, you know, you click the model and then we tell it that select this face to align and it automatically aligns and you're done, but it's really annoying. I hate it. Anyway, after that happens, we're going to arrange, it'll center. And then we get to go through our printing parameters. So I think by default, I think what I have here for defaults is probably fine. The last thing I printed was using adaptive layering. I don't think I need... Yeah, 60% infill, it's probably overkill. I have adaptive gradual infill as well, so let's see what this is going to do. 2 hours, what? That is a lot. How much infill? Yeah, we don't need that much infill. There's only 20 layers. Okay, so I guess because this is a prototype part, we're just checking it for fitment. We know we're gonna have to drill holes and everything else in it, so this is not something that's gonna be sticking around. Right now we've got 5 top and bottom layers, which is excessive. I don't know why Cure determines that's what it needs for default, so we'll tell that 2 for now. That should give us enough rigidity for that. That cuts down the time a lot. And then our infill is pretty high, which the end part I'll probably want it to remain this high just because of the fact that you're going to be, you know, pushing on the... Oh, we shouldn't be like hammering it, but you are going to be pushing on it, so we don't want too much flex. But even for that, I think 60 is high. I usually do that just because I use, like I said, the adaptive infill, which allows you to go through and create a tighter knit infill on your near your solid layers so that you don't have gaps and banding and everything else, or not banding, drooping on your layers. Can't be droopy. So let's go ahead and we'll change this from 60 probably down to 40, and that'll cut us some time too. An hour 26 minutes. That's still high. But yeah, you can see here, you can see here as it goes through the layers. By default, it's using... we've got 3 steps, so each step halves. So I think this is probably... This should be 10%. Here, right. Because half will be 20. So your main is 40%, half will be 20, and the next half will be 10. So your base, a couple layers are 10% infill, and then it's going to switch it up here to be 20% infill. And then when we get closer to the top, it didn't even do that. I guess it just determined they jumped right to 40. Maybe this is 20 then. Yeah, I'm not sure. I don't know why it's picking cubic. Let's just do grid. Yeah, that should speed things up too. Yeah. Actually, it didn't speed anything up at all. Lines? I forget which one is pretty fast. No, I actually made it slower. Nice. Beautiful. Yeah, let's go with grid. I'm not gonna fret over it. It's not that big of a deal. It's like I said, a throwaway part. So we've got that there. We've got adaptive layers on too, so I don't know. I think it's printing some more layers near the curvature parts, just so that they have a higher fidelity. And then I believe we've got a wall thickness of 2. That's probably fine for now for fitment. But one thing we do want is to, because we are considerably worried about, we don't have overhang to worry about, and we are worrying about dimensions because we're trying to put fitted parts in. What we're going to do, and I can never remember where this is or what it's even called in Cura, but basically we want to tell it to print the outer lines first. So normally when this prints, what it'll do is when you're doing the walls, it'll go and do the inner walls first and then the outer wall. That way you have support as you go out. But in this case, because we don't have overhangs, it's pretty much straight up from the build plate. we don't need to worry about that. We want to go ahead and make it do the inner layers first. That way it's more dimensionally accurate. So... I'm probably looking right at it. There it is. Outer before inner. There we go. So now if we look at it, it's not going to look any different, but it's actually doing its thing. Okay. Let's go ahead and save this to... I don't know why that... Well, you're not seeing it anyway. I don't know why it's not going to the Pi. That's awesome. Let's... Whoops. Wrong button. New folder. Nope. Poop. New folder. And this is our... Stream Deck. We'll go ahead and save this. So now... Let me hop over and switch everything so you guys can see. Switch everything so I can see. One moment here while I fart with this. I need to make a list of all the things I use so that I can easily switch through them. I don't know why that's not showing me the Chrome window I want. There we go. There we go. Okay. So this is my Octoprint layout. It's a little busted right now because I've been playing around with some things, switching the video from using the built-in MPEG streamer to something else. So my normal dashboard's a little broken. Normally it should show this, but it's not right now. So the first thing we're going to do, because I'm using Arc Welder now, is we're going to go through... We're going to open up the stream projects. We're going to open up Stream Deck. This is our exported G-code. I'm going to go ahead and click this button here to weld arcs and let Arc Welder go through. Arc Welder is a program that allows you to go through and convert a lot of your curved commands. Normally, when you slice things and you create curved commands, you'll see... actually, if I open this up, because I do have them... Let me look at a preview here. If you look at the first layer and we zoom in a bunch here, even though this is... Oh, gee, that's not good. Even though this is making a good... which one did I open? Yeah, I did open the normal one. This isn't a very big radius, but what's actually happening in here is there's not just one command going from here to here. So, like... the way G-code works, is you're literally telling the printer go from here to there, right? So when you have a straight line, like here, it's saying go from this XY coordinate to this XY coordinate, and the printer will plot a straight line. And then it's going from this XY to this XY, and it'll plot a straight line. When you have a curve, it does line approximations of curves. So the slicer will go through and say, like, you know, and it has internal limits on like how much it's going to chunk this up, but it will go through and create tons of tiny little segments, right? Tiny little straight line segments. And what can happen is sometimes when you print things out, you'll actually not get a rounded surface, you'll get an approximation of a rounded surface. And sometimes it can show up as like stuttering and weirdness. And also that means that this little segment here has more data in it than this entire giant line. Because you've got probably hundreds of little segments here versus one. You know, this is one G-code command basically, and this is hundreds. So what Arc Welder does is the newer firmware support for a lot of printers out now, and the one that I've upgraded mine to actually handle arc commands. So rather than having the slicer go ahead and create all those little commands, what it'll do is it'll give an arc command, and it'll say, like, you know, from this point to this point with an arc center point of, you know, it'll go from here, like I did, where I defined a radius in the fillet or fillet or whatever. I don't know how you're actually supposed to say. I know a fillet is a fillet, and I've also heard fillet when referred to some of the 3D printing. But I don't know what the exact pronunciation for the 3D printing part is, so we'd have to find out. But I'm going to call it a fillet because I'm hungry, apparently, and I want a steak, and that sounds good right about now for some reason. But getting back to the task at hand, what it does is the Arc Welder program goes through. So when I load this up, you won't see any difference. But the difference internally in this G-code is now this line is going from this point to this point, and there's one command going from here to here. And it tells it, like, you know, you have an arc with a center point of this, you know, which is your radius, and it leaves it up to the actual microprocessor controlling everything to tell the stepper motors in the printer to go ahead and generate that arc, rather than having to issue tons of commands and approximate an arc. It will actually generate an arc with the absolute resolution of the printer itself, which is huge because that usually generates a lot smaller prints, and it's a lot less G-code, meaning that a lot of times when you're going around corners, if your printer prints fast, it can stutter and wait because you have a relatively small bandwidth between your printer and your printer's whatever you're sending the data to. Like in my case, it's connected to a Pi, but there's only a 256 baud or bits per second connection. 256 baud. That is not right. 256k baud. There we go. Bits per second and everything. I'm probably saying the wrong terms. It's late. But you get the idea. It's restricted bandwidth. It's not like 10 megabit Ethernet where you're just shoving tons of data through, or even gigabit Ethernet we've got in our houses and everything, hopefully now, except for some of the people watching the stream and probably cursing at me right now. I'm glaring at the chat. I'm waiting for it to come. So the point is that the end result is you get smoother prints when you do a lot of curves, which I do a ton of curves because, I mean, corners look stupid. If you can make something look nice and rounded, it does look nicer in your models at the end of the day. So, or if you have like a lot of curved surfaces or whatever, like, you know, the one I did on the soldering station, I'll show in a second again. But anyway, let me get back on track. So we've got this in here, and we've got it sliced up. We've got it, you know, loaded up and everything. We've got it. We ran it through Arc Welder. We've got the top plate AWG code loaded, and so now there's nothing to do but, well, first off, let me turn around and check the printer. Sure, no, it's clear. I don't have anything on it. I cleaned it up last time, so we're good to go. Let me tell it print, and we come to the exciting process of sitting here doing nothing for an hour while it waits. So we will sit here for a while. Right now it's heating up the bed, and then we'll go through and heat up the nozzle, and then we'll go from there. This warning here is one of my plugins, basically, that is saying that I don't have the layer patterns in progress to go ahead and let this layer progress notifier spit out notifications to me. That's all this is saying. So I could just ignore those. So I guess I will end the stream here. I will probably because I don't know, it's not been reliable. Like I said, I've been changing some things with the video here, video feed of the printer itself, and it's not been 100% reliable. So I don't want to go ahead and stream it yet until I get that straightened out. But you know, we can go through and I'll come back on the next stream and we'll go through and look at the part we printed, you know, I might go ahead and make some adjustments and you know, if I need to print a, if it's really bad, I'll go ahead and make some adjustments and print out some things to do another test. But other than that, I think that's it for tonight. So we've got ahead and we've got our idea mapped out. I've got some more things to map out next time as far as the electronics diagram, like how the matrix detection works for the Arduino. I'll have all the stuff here to go through and actually test the switches and do some wiring and everything, and we should be able to go ahead and create a prototype. We should be able to figure out whether or not we need to go ahead and do the matrix or the shift register. I don't think we need to do the shift register. I think we can just go ahead and do it without it. We're not doing a lot of things. If we were doing tons of things and we had like the older microprocessors where you have very limited I/O, you'd need a shift register. Because what a shift register can do is you can go through and basically you shift bits in and out. So usually you have an 8-bit shift register, and what that means is you give it I think it's 2 pins. You give it a clock. No, it's 3 or 4 actually. You give it, what is it, clock? I'm gonna have to look it up. It's been so long. But you give it you basically give the shift register a clock signal, plus and minus. You know, you give it VCC and ground, and you give it a clock, and it gives you a pin output. You have shift in and shift out. You know, you have registers that do shift in, and you have registers that do shift out. What that means is, with 4 pins, because you've got power, ground, and everything else, you're able to then control 8 pins, because usually if you have an 8-bit shift register, you give it a clock, and what you do is you set your bit, whether you want your bit to be high or low, you know, a 1 or a 0, and then you pulse the clock. And when you do that, it moves that value out to pins 1 through 8, right? And as you increment the clock, it shifts that value through its registers until it gets to the end and falls off. And while this explanation may not make sense, what it ends up being able to do is it works in 2 directions, right? You can shift things. If you have a shift, they have better names, but if you have a shift register that works out, you can clock data out from the microprocessor into it and put it into, it's basically serial to parallel, right? If you're doing it in, you can take and read 8 inputs by going through and doing a 8 clock cycles and then reading the pin once. So you're trading time. You're basically trading time for saving pins, because whereas with 8 you could read pretty much 8 at once. They're all connected to the processor or to the microcontroller directly, which that's not really true because each read is a clock cycle anyway, but that's neither here nor there. Let's not get into that. What you're doing is you're advancing a clock and reading 1 pin value, and then you're advancing the clock and reading 1 pin value, and then you're advancing the clock and reading 1 pin value, and eventually what you get is you get the values of everything on that shift register, everything that's connected to the 8 pins, which means you could go through and you can also chain shift registers together, so you could serially read like the individual state of each key within, like if we have 16 keys, you could read the value of each individual key. With a matrix, and we'll get into this, but with a matrix you can get false positives. Like if you press more than 1 key at once, it won't always know what key you're exactly pressing. But for what we're doing, you're not gonna you're not gonna be playing a game on it or anything like that. So it's not like you're gonna be pressing like up and right at the same time and stuff like that. So that's kind of mitigated. We're not going to be worrying about that. If we were doing something like that where we needed to be able to do that, or hotkeys where we're pressing multiple keys, then we'd probably have to design it a different way. But we could probably be lazy in this case and just do a matrix. Anyhow, our printer is still warming up. It does take some time, unfortunately. Yeah, it's stabilizing the temperature for the nozzle now, and then it should be able to, you'll probably hear it before it actually, yeah, you'll probably hear it before you see it on here. because there's a delay. So now it's going to go ahead and home, and then it's going to print out and go from there. But I'm not going to make you guys hang around, and I don't think anyone's going to hang around for an hour while this thing prints out, because it's not the most interesting thing in the world. Normally I would run, like I said, my print stream, but we're not going to do that. So next time we go ahead and I log on and we're going to tackle this, we're probably going to be looking at doing a prototype with one or two of the key switches, testing out the matrix, explaining how that all works. And maybe start, once we figure out whether we need that or not, we can modify the model that we made to be the housing for just, the Arduino board or the perf board, and then figure out the design considerations we need to be able to allow the USB plug to go through and everything else. And whether or not we'll get we'll get the software running, we'll see if we can actually get it to read some key values and everything, and get it to emulate a keyboard and make sure we've got everything set up. We'll go through some of those steps. I don't know if we'd be able to get everything done at once. I mean, this isn't a huge project, but we'll have to see as we go along. So that's what I've got for now. So you can see that thing in the background going at it. It's leveling the bed right now with its probe, just making sure everything's flat and everything else. So that's it. I will talk to you all later.